today our concept is circuits. So before going to know into the subject, we have to know what is meant by the term circuit. So circuit is the interconnection of network elements. So in the definition we have the terms network elements which are interconnected. So we have to know what is meant by network elements. So in the network elements, these are categorized into two types. First one is active elements and second one is passive elements. So these active and passive elements will be called as network elements, and these elements will be interconnected to each other, which will be called as a circuit. So here active elements consist of voltage source, current source, and the passive elements consist of resistor, inductor and capacitor. Here voltage source, current source. Active elements ante enti ante here voltage source and current source should deliver energy to the remaining elements. So this have the capability of delivering energy to the other elements. So these are called as active elements, and the elements which have the capability of absorbing the energy are called as passive elements. Here resistor, inductor and capacitor. These are the symbols of passive elements. And another main concept in the circuits is KVL, KCL, by which we can understand the behavior of this network elements. So the next concept is KVL, which is called as Kirchhoff's voltage law. In the definition of Kirchhoff's voltage law is the algebraic sum of voltages in a closed loop is equals to 0. Now we will explain this KVL by taking a simple example. So considering elements. So as we said, the elements, interconnection of elements are called as network elements. Now we will see in this circuit what are active elements and what are passive elements. So considering this as an voltage source, so as we said, voltage source comes under active element, and these are resistors, considering it as R1, R2 and R3, and this comes under passive elements. So as we discussed, active element should deliver energy to the other elements. So here the voltage source will give energy to the remaining elements R1, R2 and R3. So according to the definition of KVL, algebraic sum of voltages across the elements is equals to 0. So the voltages. So when current passes through the resistor, there will be a voltage drop across R1, considering it as V1, and the voltage drop across R2 will be considered as V2, and the voltage drop across R3 is considered as V3. Now the algebraic sum of voltages. We have to add all the voltages in the circuit. So adding the voltages V1 plus V2 plus V3. So the circuit starts from this side and the circuit will end at this point. So considering the voltage as capital V, so the polarities become plus and minus because the current always flows from the positive side. So when the current reaches to this point, which is the negative, so here we can write it as minus V is equals to 0. So V1 plus V2 plus V3 minus V is equals to 0. Now we can substitute V1, V2, V3 with the terms I into R. As we know from Ohm's law, V is equals to I into R. Substituting V1 is equals to I into R. As we know, when the elements are connected in series, the current will be same in the all resistor. Considering the current as I, which is flowing through the circuit, the current will be same in R1, R2 and R3. So we are writing I into R1 and V2 is equals to, as the current is same, I into R2 and V3 is equals to I into R3. Substituting these values in the KVL equation, IR1 plus IR2 plus IR3 minus V is equals to 0. Taking I common, I into R1 plus R2 plus R3 as it has a minus term. When it goes to the other side, that will become plus is equals to V. And we get V is equals to I is equals to V divided by R1 plus R2 plus R3. So for the example, we have taken the terms as V, R1, R2 and R3. If we take the numericals for these resistors, we will get the current value. For example, if V is equals to 10 and R1 is equals to 1, R2 is equals to 2 and R3 is equals to 3. By substituting these values in the current equation here, we get exact value of current that is flowing through the circuit. So, by using KVL, we can find the voltage drops of each resistor. But here we have found the value of current. So, by using this value of current, we need to find the value of voltage drops across these resistors. So, how can we find? We know we have written V1 is equals to I into R1 from the Ohm's law. So, now we can write V1 is equals to I into R1. As we said that we get some exact value of current here, that will be substituted here. Considering this as 2 amps, we get 2 into, assuming R1 as 1 here, 2 into 1, we get 2 volts. So the voltage drop across R1 resistor is 2 volts. Similarly, we can find voltage drops across R2 resistor, the same equation, I into R2, as the current is common. Because this is a series circuit, 2 into, we considered R2 as 2, so we get 4 volts. And similarly, V3 is equals to I into R3, we get 2 into, R3 is considered as 3 into 3, we get 6. So this is the procedure to find voltage drops across the resistors when these are connected in series. This KVL is applicable for this circuit when these resistors are connected in series. So, in simple way we can say that KVL is a method to find the voltage drops across the resistors. So, this is the procedure we have to follow in order to find out the voltages across the resistors. So, we have discussed this by taking the example, by simple example. So, this is the concept KVL, which is Kirchhoff's voltage law. Thank you.
Thank you.